Hello. In this short video, we'll take a look at configuration management for the maintenance, repair, and overhaul, or MRO, phase of the product lifecycle. To illustrate how CM applies to this phase, we'll describe some challenges MRO stakeholders face and take a look at how a CM-focused tool can meet those challenges to better serve this community of users. We'll take a look at necessary capabilities in a CM software system by running through a realistic example of as-built configuration data, which is central to performing supply and service chain tasks. MRO users need interfaces that are easily digested, searched, and manipulated with minimal training, and that have standards-based CM rules and practices built in, providing complete product history and traceability. This example will illustrate the definition of configuration and associated product data, establishment of the as-built configuration, and how changes to it can be processed during the service life through disposal. In our previous CMsites blogs, we've noted that the majority of users of PLM data are not in the engineering or even the CM department. These consumers of product data have a need for CM data that extends throughout the lifecycle, past design, development, and build, into operations, service, and maintenance. They have as much need for maintaining trustworthy configuration data as those in the earlier stages of product development. The throughput of change in the later stages of the lifecycle are in many cases even higher. These downstream users need access to the data presented in a logical way with the views of specific data elements they require. This starts, of course, with correct organization of configuration baselines and associating product data to them. CM principles are essential to efficiently establish and verify the configuration baseline against which these changes will be processed during the service life and through disposal. Whether they realize it or not, everyone ends up using configuration management data. So what functional roles are we talking about when we look at MRO? The user types listed here, even if they're within OEMs, may still have challenges accessing PLM data. For some organizations, contractual and licensing limitations or the environment in which they're working don't allow downstream users access to the original PLM toolset and database. At CMstat, we've often worked with customers who perform maintenance and overhaul with little or no original product design data. In these cases, physical surveys are often used to create a baseline from which to plan, devise, and detail solutions to problems encountered during operation and maintenance. The need for the digital thread is a given when managing products in today's environment. When end-to-end connectivity is possible, data can be transformed into true business intelligence. Many companies, however, still struggle to achieve this ideal and are in need of tools that can provide the needed capabilities as they transition into a fully digital environment, to tie up those loose ends, if you will. Whether the digital thread is maintained and accessible or not, CM is equally as important to MRO organizations as it is to the original manufacturer. All principles of configuration management apply to these later phases of the lifecycle, and the benefits of performing good CM are the same as they are for design and development. Clear requirements, clear communication, established baselines from which to perform change, accurate status accounting, complete and correct change impact assessment, and the list goes on. MRO users have a need for CM functions such as change control, product structure management, and update, identification frameworks, and of course, configuration status accounting. The ability to begin with a product structure and then capture and manage the true physical instance data of a product is a basic starting point, but is not always easy to achieve. These physical instances are defined by the as built, as tested, as modified, as delivered, etc. We refer to all of these as the as-X or as configured data sets. These data sets should include reference to models, product data, documentation, as well as specific serial numbers, software versions, barcodes, certification tests, work orders, quality information, shipment details, and all of the other tracking data needed for status accounting and ongoing logistics service and support. A good point to be made here is that the complete product structure often goes beyond what is defined in a CAD model. The overall product structure starts with a definition of the entire product, but also includes elements such as enabling software operating systems, supporting files or configuration settings, interface control requirements, and other operating environment details that must also be represented to paint a comprehensive picture of what must be in place in order for the product to function. This approach to product structure results in a truly comprehensive set of capabilities, infrastructure, and physical and logical components that must be present in order for today's complex and connected products to fulfill their intended use. If any of these pieces of the puzzle are missing, the product can't be reproduced, nor can it be managed correctly. Now let's take a look at how that works in a CM tool. We'll start with the product definition, and in this case, the indentured breakdown gives that view. All elements of the product structure, including hardware, software, firmware, and documentation, combine into the product structure. All cross-references to defining data, such as CAD models, bills of material, alternate or substitute parts, and other details of configuration data are linked, of course. Change history is tracked for all of these data types with built-in user-tailorable processes and automation where appropriate. This is the foundation upon which a baseline will be developed and leveraged into the as-built or as-ex configuration. Next, we'll look at a configuration record for a specific instance of the product. The one I've retrieved is an as-built record of a product configuration that's been through certification testing. These as-configured records, as we call them, start with the product structure data we were just looking at to establish the baseline. Functionality within EPOCH allows for manipulation of that data to reflect the true real-world configuration of the product, including alternate or substitute parts usage, adding in spares, incorporation of approved changes to subassemblies, just to name a few examples. Detaching an assembly parks that data in its own record to maintain the maintenance and change history when it's refurbished and reused in another instance. When the record's in its final state, it contains all of the parent-child relationships between assemblies and subassemblies and their components. Controlling and supporting documentation and data. Tracking number details such as serial numbers, software version, barcodes, IUID, and other identifying numbers for controlled parts and assets. And certification that has been performed on subassemblies or for the end item itself, as we saw in the beginning of this record, are also important to capture what testing has been done. This instance of the product can be managed over its lifetime with revisions of the record to maintain traceability and provide a way to track change incorporation, who authorized and carried out warranty work, swap out of serialized components, and any other actions taken throughout its life. The history is preserved, thereby maintaining the digital thread. Capturing changes within products that are in the operation phase is one of the biggest hurdles companies have maintaining product configuration data. One way to ease that is to provide capability to quickly update or automate the import of data in real time. Having this information accessible to all stakeholders in one place gives users a common starting point for collaborating on problem solving, performance analysis, and also provides a framework for feedback loops that are so necessary in product management processes. In summary, CM tools that serve downstream users of product configuration data, as well as the engineering, design, and development stakeholders, must have the following attributes: be quick and easy to install, upgrade, and maintain. Be intuitive, supporting logical data relationships, reducing training time. Allow for automating maintenance of product structure data where appropriate. Provide detailed tracking of the multitude of identifiers associated with varying asset types. And of course, traceability and history must be maintained throughout the entire product lifecycle while providing the ability to link to other systems in real time. Thank you for watching this video blog. If you'd like further information, please subscribe to our blog to receive updates on configuration management, data management, or our products, or you can visit our website at www.cmstat.com.